Hello, everyone. I'm Dan Powers, Executive Director of the Society for Science at User Research Facilities, and we're starting another session of our 2022 annual meeting. Right now, we're going to be hearing from Andrew Wiedlea with ESnet regarding the ESnet system, in fact, the ESnet6 recent upgrade. Let me give you a little background on ESnet and then also Andrew, and then he'll be joining us here. The ESnet is really the shortened name. The Energy Science Network is the Department of Energy's dedicated high-speed network for the data of tens of thousands of scientists and researchers operating every single day. And the capacity that ESnet provides is a resource unlike any other, and actually something that every scientist should be aware of if they're still using any kind of either localized or off-site or even the old school sort of hard drives that you would be able to disconnect and take back to your house. ESnet may very likely be a much better, more secure, and faster option, more efficient option. This new upgrade to ESnet, known as ESnet6, provides new capabilities such as an expanded dedicated fiber optic backbone comprising of over 15,000 miles of fiber optic cable, a new network automation capabilities, a new platform that allows ESnet to monitor data in real time and monitor overall network performance, and also enhanced cybersecurity and other resiliency protocols. So that's what Andrew will be talking about. And I'll give you a little bit of background on Andrew then. He is with ESnet supporting their users and mission through any means necessary. I like the reference from his biography saying, pardon me, that any day spent solving science use case problems is a good day. He's been with ESnet, which is located at the Lawrence Berkeley National Lab for roughly 7-8 years, if I'm correct. And prior to that, he was also the chief of advanced analytics program with the Defense Threat Reduction Agency from 2008 to 2016, and also served with Los Alamos National Laboratory in the development of statistical tools and methods for the years before that, from 1998 to 2008. Very much a expert within the protocols and the nuances of federal agencies and federal research labs that way. So let me welcome onto the screen Andrew Wiedlea.
Thank you very much, Dan, and it's a pleasure to be here with everyone this morning. All right, so I'm going to talk a little bit about ESnet6, but I'm also going to talk a little bit about one of the most exciting parts of ESnet6, which is really thinking about the service models and the relationship that we want to build between user facilities as we share the capabilities of this new network that we've built. And this is also, I'm part of the science engagement team. So this is a work underway, being supported by Eli Dart and Jason Zarowski and Lauren Rotman and Ken and really the full suite of folks who work at ESnet. So it's kind of really exciting time for us. So as Dan mentioned, we recently unveiled ESnet6. And this is a generational shift for us. This ESnet6 was sort of 8 years in planning and building. And this was a major DOE project that took, about 50 or I think it was $150 million. So it's a major investment by the country in scientific networking and the capabilities to support user facilities. ESnet supports sort of the research across all of the scientific complex of the Department of Energy. And we basically move sort of all of the unclassified traffic between the national lab sites. So ESnet6 is a major point of inflection for the country. At the simplest level, it was certainly a great increase in backbone capacity. We increased bandwidth to about 46 terabits per second. And that's absolutely necessary because across the complex, scientific traffic is growing at a rate of doubling. It's sort of growing by a factor of 10 every 4 years. So, it doesn't take long at sort of those rates of growth to quickly outstrip any capacity you want to have. But it's also more than just, expansion of fiber optic cables and capabilities across the country. It also includes a lot of work on automation, a lot of work on cyber capabilities and traffic monitoring, and a lot of other technical innovations, which I'll talk about briefly. But it also includes sort of a lot of work on the service model, and that's something that I'm also going to talk about. So, ESnet6 is really, it's more than just, bandwidth increase. It really is part of a new vision that we're starting to develop for scientific networking, and kind of how scientific networking and scientific compute and edge activities, things like operation of sensors or light sources or other facilities integrate. And there's part of this is being driven sort of philosophically and sort of across the complex through things like the Office of Science's Integrated Research Initiative, and things that are working to sort of tie the activities of science more tightly together to support scientific efficiency. But also, frankly, it's also because of new technology and new capabilities, sort of what a network is and what it performs is also starting to change. Traditionally, networking has been very much about keeping the packets flowing and keeping sites connected, and bringing traffic from scientific instruments to high performance compute resources that are located in central nodes. Increasingly, those workflows are starting to become much more complicated as things like edge compute and advanced wireless and Internet of Things starts to become more and more important for scientific activities. And so what that means is that the network itself is becoming an end-to-end analytic and data management resource. So ESnet6 has been built with this new sort of architecture in mind. And while sort of features will continue to develop on this platform, we also envision that it'll become a space where users themselves are beginning to deploy analytic applications and analytic capabilities into it. So in addition to the bandwidth, we also are working heavily to make the network sort of more accessible, make it possible for users to actually better understand how their traffic is moving around the network, developing a set of APIs so that software-defined networking and other resources that may be deployed in the network are available. We want to make it more transparent so that resources are more generally available and the service can be better tracked. But it's also more controllable in terms of a network. So we're using sort of a hollow core architecture that we envision, where workflows, more complex workflows can be better characterized, and workflows themselves may be characterized in terms of like the resources available, the workflow analytic needs, the timeframes in which things have to occur. And that should support greater synchronization and ability to link together high performance compute resources or sensors or different parts of the network and storage together. And then also we want to make the network more adaptable. So, ability to integrate computing and storage into the network itself. We're sort of seeing a melanging of resources both on the compute and storage and networking side to provide sort of integrated sets of capabilities. Whereas before these were very distinct data management tasks. And then also to support rapid prototyping by ourselves through things like our own testbed and our own network research programs, but also in coordination with other research and engineering networks and other user facilities. So really exciting to see sort of how this fermentation may happen and what may happen over sort of over the next decade as these things come together. But any technology is not operated in isolation. Really, what we're deploying, and the map behind me is, sort of the picture of this continental framework. Even, it's both the U.S. and then also, frankly, extending up into across the continent to Europe and to CERN, is really part of not just a technology set of advances, but also a social set of advances in terms of exploring sort of how the service models will change. And a big thing that we're starting to emphasize and really become very excited about is this idea of sort of co-design. In fact, that's now one of the main pillars, or sort of crosswalks anyway, maybe not a pillar, maybe it's a horizontal thing, frameworks or platforms for this whole system. So what we envision doing is becoming much more a part of the analytic process and analytic design process that occurs within a scientific project. And so it's changing how on the science engagement team, we are beginning to work with customers and scientific partners. But it's also that creates changes sort of throughout the whole ESnet organization to be able to support these kinds of things. So while outsiders may sort of see the technology part, the part behind me that's on the map in terms of sort of being the major change for ESnet6, probably one of the most important, equally important set of changes that are occurring within ESnet are internal, as we think about the structure of the organization and how we coordinate things internally to manage the more complex processes that are imagined by a co-design interaction with partners. So what is co-design? So, really increasingly what's happening across sort of user facilities, across science science campaigns that are occurring, is that facilities are starting to have to work together in more connected ways, to work together to do multi-phenomenon explorations or analytics. We're seeing campaigns that span, biological facilities, light sources, and things that it may occur at places like the Joint Genome Institute for different types of genomic samples. So, for example, campaigns to collect soils from different parts of the world, which may lead to sort of multiple cryo-EM and metabolic studies, and then also DNA assessments, as well as also physical modeling that may occur at a high-performance compute facility. And so you're seeing workflows that are not just about sort of collecting data, bringing that data back to an HPC or a storage resource, doing analytics on it, and then sharing the data and publishing papers, but you're seeing campaigns that kind of begin to span different user facilities and different disciplines. And as these projects come together, networking and being able to coordinate these activities, move the data where it's needed, and free scientists from geographical constraints really becomes an increasing part of that has to be designed into the process, into the workflows, and into the design considerations from the start. And so that's really what we're trying to work towards within ESnet. It's really an activity to more actively at the start of projects seek out opportunities to work with the scientists to understand what their data management needs are going to be. Understand the analytic processes, understand the science, and then begin to help bake in the capabilities of the network at the start of the process as needed. So we have sort of a number of engagements underway. This does change sort of a lot of how we engage with scientific projects, the kind of labor and intensity of involvement that are involved in the process. One of the co-design sort of efforts underway, we were working on the Gamma Ray Energy Tracking Array, or GRETA. And this is a really exciting new instrument that's being built at LBL for deployment at FRED. And really what it's going to allow scientists to do is, as nuclei are being bombarded with heavy ion particle streams, you're going to be able to observe with three-dimensional resolution the gamma ray emissions and decay of those nuclei into daughter products in real time. And so the instrument itself is fiendishly complex. It's 120 germanium crystals that are tiling a sphere to pick up all these collisions and capture both their direction and their energy. And then a tremendous amount of sort of parallel online data reduction and analysis is required to make it work. So when in operation, GRETA is going to be tracking about 500,000 trajectories per second from the instrument. And then there's a very rigid set of very fast requirements to resolve the trajectories and the energy levels and provide that information within sort of a matter of minutes to allow users to then recalibrate beam activities. This all depends, of course, also on the ability of very fast electronics, and particularly a lot of use of FPGA capabilities, which are very expensive to program and very difficult to put together. And This is really an activity where we've been embedded from the start, really as part of the project team, and part of the team within the science engagement group has been funded by the project to be directly involved in sort of all aspects of this, from the design of the algorithms that are going to be used to the creation of sort of the back-end compute resources and the capabilities to pull data out from the crystal structure, from the high HPG crystals, and then resolve the energy and direction very quickly. And it really is cross-disciplinary, involving sort of networking and high-performance software and software architecture and design, system design, and has been required sort of 4 or 5 years of engagement from members of the ESnet team. So this is a case where, you know, co-design really means like embedded activity with a very high amount of involvement in the fundamentals of the technology. Another co-design case that has a different kind of support model has been our work with the ARES project, which is ARES is the Advanced Research on Integrated Energy Systems. And this is a project out of NREL that's really trying to develop a way to tie together multiple lab simulations of different parts of the energy grid to allow, you know, sort of complex explorations for things like, you know, what will it mean when, say, wind production provides a major component, you know, is an increasingly large component of energy. And then it's also being tied to energy storage systems, such as, like, say, hot sodium battery systems. And trying to figure out, okay, how will that work then to provide stable and reliable electrical power during operation, and how might these technologies support grid resilience in the case of disruptions? So the idea here is that you want to be able to tie together multiple labs. The vision is that people want to be able to ultimately simulate up to 10,000 devices working together between different laboratories, and possibly also integrate real devices on, say, test energy grids into this framework. And so that's something where there's been sort of repeated sets of tests between INL, NREL, PNNL, Oak Ridge is also involved, Sandia, and future activities may involve LBL and other labs. And the idea is that you want to have this be sort of a permanent resource that allows these simulation tools to rapidly be deployed with one another. And this is really a case where we've been involved from the standpoint of, you know, creating sort of virtual proximity via the network. This has not been a problem primarily of network design from the standpoint of bandwidth. It's not moving a terribly large amount of information, but what we do need to do is make the network perform as a non-stochastic instrument. Basically, we need latency to be very predictable. We need very low jitter so that simulation codes across different laboratories can maintain synchronization and reliability and sort of in the arrival of packets. We've been successful in an exercise that was run last year. We're doing another exercise in about a month. But this is a very different use of the network, and it's also a very different use of the co-design model. We've been part of that team, and we've been supporting with sort of system engineering and deployment of network resources in conjunction with our network operations staff. But it hasn't required the same level of sort of primary technology development that that Greta has. So you know, it's an opportunity where we're sort of providing integration support, and we're leveraging capabilities the ESnet6 provides organically because of the way that the network's been built. But then as exercises occur, we ramp up and ramp down periodically to support that model. You know, we have a number of other similar kind of capabilities. We're working in advanced wireless with folks in outside Crested Butte, Colorado, working on private wireless systems to explore how we integrate those in. But at the same time, we're also working with field scientists to understand how we deploy these sets of capabilities. We're working with folks who are doing planning for some of the telescopes in the Atacama Desert. And so, you know, really what we're starting to learn are the lessons in terms of what it takes to operate ESnet6 and the capabilities as part of a co-design process. You know, some of the lessons learned already is that definitely requires sort of an embedded concierge service model. You know, this is not ticket activity. This is developing long-term relationships, understanding what people need, understanding what the cycles in their system planning are, and then involving ourselves however needed to support their needs. And that can be from very early stages in sort of concept design all the way to, later stages of implementation. It's also forced us to think about new venues for exchange of information. So in October, we held our first confab, which is our yearly user meeting. It's very much sort of like this meeting that SSURF is holding. And some folks on this call may have attended that. And that's going to be a new yearly cycle where we're going to invite sort of everyone that we work with to come and be a part of this activity. And help build those relationships that we need for follow-on sort of co-design relationships. It's definitely all multidisciplinary and sort of multi-dimensions of support are needed. We're willing to do everything from make people coffee to help write papers to help development technologies. It's sort of figuring out what's needed really depends on managing that relationship over time. But we're definitely excited about being able to do that. And it has huge impact on the ESnet organization in terms of figuring out like, okay, so how do we internally manage our limited resources and our capabilities and the fact that we also have to run the network in a steady state for everyone while we support these scientific projects. So there's thinking to do about how we manage resources, how we trade off our own internal programmatic needs with things that may be occurring with co-design activities, how we staff, where people are assigned, how people are assigned, and you're seeing some of that with those new platforms that are being developed to sort of cross-matrix people. But then also information and provision and availability is just as important. So we also want to make people not dependent on us in terms of, so a co-design process has to occur. We have to stand up the ability to support a specific scientific project. But at some point, things have to transition to a steady state. And then we have to go off and help other folks. So figuring out how to teach people enough and to provide enough capabilities through APIs and other sets of resources so that as their scientific project develops and begins to flourish, we can stand back in our support and they just have the capabilities that they need from the network. That's also very important. So these are all things that are being worked out, and there's no magic answer to it besides engaging with the projects and getting your hands dirty and working that way. So, we get by with a little help from our user facility friends. This is why things like SSURF are important. We need to, use organizations like this to build the kind of relationships that we need with you. We are kind of unique in the user facility space in that we are not a place. We have a headquarters at LBL, obviously, but our people are scattered all over the country, and we work, in a distributed way sort of all the time. We have our site site committee members. We also have people who are distributed all over the country. We're very eager to get involved with user facility science effort planning early and often, very excited to engage with anyone following this talk or from similar venues interested in starting a process. Sort of in conclusion, the architecture of our network to ESnet6 is really a socio-technical development, not just a technical development. The socio part of it and the development of this new sort of service model is underway. We haven't got it all solved yet. It may never be, spick and span. It's something you sort of have to figure out based on what the needs of the community are. But we're very excited about being able to provide new kinds of streaming and edge analytic services and seeing how we can support science, the science community through service models that enable those. Our mission is to free scientists from geographic constraints, and that's both sort of on the technology side and also on the planning and whatever else is required to make the science happen. We're eager to engage with you early and often, and thank you very much for this chance to talk a little bit about what's happening under the hood.
Great. Thank you very much, Andrew. I'm curious, as just a quick question, would there be a type of technology or a realm of certain or research occurring at labs that you perceive as being quite relevant or even ready as prospects to engage with in some of these co-design projects?
Our mission space covers everything. And so, we're increasingly, traditionally we've been focused on sort of user facility needs, things like light sources and high energy physics and defined places. But we're increasingly becoming also more involved with field science activities as scientists are increasingly deploying instruments out into the, into the wild. So, and of course, the network demands for those different kinds of science are radically different. So no, I think basically our mission is to support science regardless of sort of disciplinary, background or source within the complex. We're really a resource, that's supposed to enable everyone. And so I don't really think there's I think there are definitely some models that are more traditional in terms of we've been working with folks for a long time, but there's also some new communities that I think we need to do a better job reaching out to.
Okay. Well, that wasn't meant to be such a prompting question, but what you've just answered makes me think we would like to help be a convener for those additional conversations with prospective communities. There's more we can follow up on. And I'm sure, as you know, Lauren Rotman on your team is a prior SSURF board director, and she's very aware of our mission and the aspirations we have for continued activities in 2023. So we'll stay in touch.
Thank you.
Thank you very much for making the time today, Andrew.
Thanks very much for having me.
All right.